Kind of been a long day for everyone, so I'm gonna try to have some fun here. My name is Josh, the founder and CEO of Daly Energy. We're a new product. Maybe a few of you have heard of us, probably not though. So we were founded over a little bit over a year ago. Our team split between San Francisco and Ukraine. Our first API was released in May, and we're launching the web interface, which I'll talk about here in a second, at SBI. Probably talk a bit. We're getting our independent engineer, third-party review done right now. There's 5 of us total. So kind of our mandate is to take sort of the industry standard and financeable models and put them in a broader cloud ecosystem with more functionality and more capabilities. That's kind of the straightforward outline, but basically it can be broken down into 3 components. The web interface, which is a cloud-based UX UI that has reports and weather reporting automation, as well as all the inputs and usual good stuff you find in a production modeling tool. We're an API forward platform, so everything's focused on being automatable or touchable with an API. And then the final part is integration with third-party software. So you might see us soon in other softwares, and all 3 of these are related back to the model. So if you, let's say, interact with the API, it'll surface on the web interface. Or if you're doing some work in a design tool, you'll be able to pull that information from the API. So it's kind of a whole ecosystem you should be able to leverage. It is a solar and storage platform. The storage part is still not released yet, but the solar platform is kind of fully baked and ready for use. That's what I'm going to focus on today. Okay, so a little bit about kind of where I'm going to take the rest of this. There's a lot to talk about, and you guys are probably all familiar with production modeling tools. So I want to focus on 1 or 2 things that we're especially proud of, and that's basically 3D modeling. So we do have a 2D near shade engine, which is kind of your unlimited normal view, and then we have Octavia, which is our 3-dimensional modeling platform. It has a couple unique features, one of them being a diode protected area, so you can model diodes in 3 dimensions. And the other thing is it has a built-in terrain-aware tracking. And you can upload into Octavia from exporting from PV Complete or PVC files, shape files. If you have some other format that you're interested in, it's pretty easy to upload those, so let me know. You can add them in. So a little bit about terrain-aware tracking. We're analyzing every table in a scene independently, and we're determining tracking schemes for each sun position. Direct and diffuse irradiance is all measured and calculated independently. And we can reference module architecture through the diodes to make decisions about if we should track or not. And a little bit more about these transverse diodes, just to give you kind of a flavor about what I'm going to talk about in a minute. Essentially, we have in 3 dimensions, we're modeling the shadows as well as their impacts on the electrical architecture. And we use this to inform the terrain-aware tracking, as well as compute electrical loss. So Octavia is accessible through an API. You can post those files I mentioned. It processes, it usually takes less than 10 minutes. And then you can reference that shading scene in a bunch of different ways at runtime with the energy model. So I just kind of blew through that. There's a lot more of the platform. There's sub-hourly stuff we're working on, building a storage component, like I mentioned. But I want to walk you through the 3-dimensional thing, like I said. So we're going to go through a little example project real quick and see if we can have some fun here at the end. So we're going to talk about this project specifically. It's 700 tables, kind of this, you're looking south, so there's kind of a east-west slope to it. And what I've done is uploaded both these into PVSys and Daly, and you can see the comparison numbers. Basically, the 2D scene is identical nearly, and then the 3D scene is pretty close. So these are just kind of keep these numbers in mind. We're going to kind of go off into the woods here and tinker around. So this is kind of your starting point, so to speak. So the first thing to look at would be just kind of adding in terrain aware tracking. And we get almost a 7.5% gain. Everyone's seen the graph on the right a bunch of times. You're getting most of the energy gain in the shoulders. So fairly straightforward. However, what we can do also is add in half cells. So what we've done here is that's the same comparison on the left, but on the right, we've added, basically, we're looking at having a center busbar module and how that affects the yield numbers. So you can see that just by adding a half cell module to a standard flat backtracking, which means that it's not aware of the neighbors and the relative differences in elevation, cuts the gain down a little bit. And then the half cell terrain aware is just a small improvement of the full cell. So I think it might be a little confusing, but if there's any questions at the end, I'm happy to talk about them more. And so finally, I kind of wanted to ask the question, is there anything we're missing? Is there anything that you've done differently in terrain aware? And so the question I wanted to ask was about half cells. So is there like a different tracking schedule for half cell modules? So just to talk about this a little bit, in Daly, in our activity, you can set limits or thresholds for how many diodes or how much of the table you're interested or you don't care about being shaded. So in this scene, we set the limit at 6. So basically that shadow is blocking 6 along the transverse direction. And in the next one, set it to 3. So the angles are cut down a little bit further. So this is just an example of how you can control the tracking algorithm if you're interested in doing that. But the results kind of show that it's not necessarily that big of an improvement, and it's actually a drawback in some cases. So those numbers on the left I showed you 3 slides ago. And this is basically a half cell specific terrain aware tracking algorithm where we're saying we don't care if the bottom half is shaded, essentially. So instead of tilting all the way to flat to avoid all shadows, we're going to the halfway point. So yeah, that's it.